Hello, and welcome to our new edition of Coffee Talk, the COVID edition, where we're still brewing up curiosity along the country, but this time we are quarantined. We must stay in the state.
New York.
6 feet away.
New York. Absolutely.
New York.
Cheers, Miss Meniscus.
Cheers.
There we go. Cheers. All right. I'm ready to go. This is interesting. This is new.
This is new.
This is new. This is, we have to get all techie with the times and stay safe and everything like that. And
it's different, but still awesome.
Yep, different but awesome. I love it. All right, let's get going. I'm excited. New York edition. New York.
All right. So, as you would guess, all our viewers, they are from New York.
Okay. Very good.
So I don't know if we've ever heard of this place, but the Hamptons, out in the Hamptons.
We do have a special guest today. We've got two special guests.
Oh, we have to introduce them.
Yes, we have to. Well, first, everybody remembers Bones.
Oh, Bones. Thanks for coming back.
Yes, Bones has been, he's all masked up for me and everything like that. So we've been quarantining together in class. So he's all set. He's ready to go.
Very nice.
And our mystery guest for the day.
Whoa.
DNA.
It almost looks like you have a secret twisted ladder behind you.
Yep, that's it. DNA is twisted. He's a twisted guy.
It looks like it. It looks like you can go up that ladder and go somewhere.
You could, as long as you go in circles like this.
Oh.
Yep. Interesting.
I like it.
All righty. Here we go.
Thank you, DNA, for coming and joining us on our COVID edition of Coffee Talk.
Yes.
And Mr. Stein, I'm ready for your question, okay?
Okay, I'm ready.
All right. So this is from Bernie.
Hi, Bernie.
He's been weekending in the Hamptons.
Weekending. Very nice.
And what he says is, I just don't get it. Why do I look so different than my own siblings?
Oh, Bernie. That's because of your DNA, our special guest here. Okay. Our special guest, DNA, first of all, it stands for this big long name called deoxyribonucleic acid.
Oh, boy.
That's a lot to say. So that's why we shorten it to DNA. Okay. Now, DNA, it's called a double helix. It's like a twisted ladder. That's what it means. And it's the instruction booklet to make you who you are. Okay. It codes for everything. It codes for your hair color, your eye color, how tall you're going to be, how short you're going to be. Every single thing about you is coded by our guest, DNA.
It's like a recipe book in there.
It is a recipe. Yes, it is a recipe. And all the letters, it's millions and millions of letters long. And they all stand for something. And they come out in different orders. Okay. And the different orders of the DNA code for your different traits, whether you're going to have brown hair, gray hair, no hair, all of that kind of stuff. So DNA codes to make everybody look a little different because our DNA blends us together from our moms and our dads and stuff like that.
You forgot the blonde hair.
The blonde hair. Yes. You have very nice blonde hair. It's coded in there. It's in your DNA.
My DNA.
It's in your DNA. That's
so
right.
If I have different color hair than a sibling, I could look different, even though I'm a sibling.
Absolutely. Absolutely.
We have different DNA.
Mm-hmm. Now, most of our DNA, even with other organisms, is very similar. We're very closely related to lots of different organisms out there. But our DNA is specific to us as an individual.
That's wild.
Crazy. Right?
Oh, boy. This is going to be a great show.
I like it. If I go like this, it looks like I'm looking at you. Hi. Cheers.
Cheers.
Cheers. All right. We've got another question here. This is from Diane in Saratoga.
Oh, where the horses are.
Where the horses are. That's right. Yes, that's where the horses are. Diane asks, are mutations real like in X-Men? I love X-Men.
I mean, I haven't heard any real mutations that make us like Teenage Mutant Ninja Turtles or X-Men. But
that would be cool. I would like superpowers.
I would like some superpowers too, myself. But I will tell you, mutations are very real. Ooh. They can happen. So what a mutation is a random change in your DNA. Poof! Mutation.
Oh, okay.
Mutation. You got to protect that DNA molecule back there from mutations.
Yeah.
That's why we have it in the nucleus. It's really protected. It's not in the cell, in the nucleus. And we keep it in there because that recipe that we were talking about, that code, we want to keep it the same. Every time we make more cells, we want to keep it the same, keep it the same, keep it the same. But guess what? If it gets a mutation, That recipe got changed. Now, let me tell you a story. You ever make chocolate chip cookies and instead of using sugar, you use salt?
Oh, that
It don't taste very good.
doesn't taste
That's
very
like
good.
a mutation. So
Okay.
I substitute or I take out one of these things, one of these bases, and I got the wrong recipe.
So you're saying our DNA that I just talked about, just the letters change around on it?
They could.
Whoa.
Yeah, that's why you got to stay out of the sun, UV,
Mm-hmm.
right? No tanning beds, no
tanning.
smoking.
No, it's bad for you. Smoking bad. Yep.
Chemicals. No, you guys to keep out. No mutations for me.
Oh.
You know?
Okay.
Because they could be bad. Not always. Sometimes they just, that's how we got so different. Random changes. But some mutations could be bad.
Yeah, mutations. Yeah, a lot of them are bad, but there are some good ones that help us.
Yeah, I agree.
All right, very good. Cool. Mutations.
Stay away from all those toxic chemicals, will you?
You're not going to get superpowers, but you could end up with some pretty cool characteristics.
Maybe.
All right, cool. Very good.
I have a question for you.
All right, let's hear it.
I think you're going to like this one because I happen to know something about you, the Stein family.
I'm excited.
Yeah. All right, so this one comes from Colosino. He lives in the Bronx.
Colosino from the Bronx. Hello.
Yes.
Colosino.
He's a cute little kid.
I've never heard that name before.
Never?
No.
You know, I remember from some movie I watched one day. I can't remember. It says, if I'm allergic to dogs, which that stinks. My mom's allergic to dogs. I understand.
Oh, me too.
Is there a dog that would not make me sneeze?
There are. And you can even get combinations of dogs.
What?
Yes. So I'm allergic to dogs. Same thing happened with Mr. Stein and Mr. Stein's family. I'm allergic to dogs, but we wanted a big certain type of dog. We wanted to get a lab, but Mr. Stein, I'm allergic to them.
No bueno.
No bueno. So what we ended up getting was a golden doodle. It was part golden retriever and part poodle. So what happens is breeders are people that mate dogs together. They breed different dogs together to get specific characteristics out of them that are beneficial. This is a fancy word for this. Ready? Because we're selecting what traits we want. So it's called selective. And because we're mating them together, what do you think?
Mating.
Nope. Close. Starts with letter B.
Breeding.
Breeding. Very good. Selective breeding. You're so smart, isn't it? You're so smart.
Where do they do it? Where do they come up with these names? I can't.
So selective breeding is when you breed animals together, to get desirable characteristics of what you want. We're selecting what we want. And then they mate, and then those characteristics come out. And so you could get any kind of dog that you want.
That's amazing.
Yeah, it's amazing. Yep. Our puppy definitely runs the house now. She's 10 months old, 45 pounds, and thinks she's a big lap dog. She goes jumping right on you. Boom.
That puppy. What's the puppy's name again? The dog?
Dakota
Stein. I love it.
Yep. All right.
And you don't sneeze, right?
What's that?
And you're never sneezing.
No sneezing. That's the desirable characteristic I needed. We need to select that.
That's fantastic.
Yeah,
thank you for sharing that, Mrs. Stein. That was nice.
People have been doing selective breeding for a long time. Farmers do it, different breeders, horse racers. Selective breeding is happening all over the place.
Not a new thing, then.
Not a new thing. Nope, not a new thing. Nope. All because of DNA. DNA. All right, I've got another question for you.
Ready.
All right, here we go. How are farmers and scientists getting bigger and juicier tomatoes? This is from Joseph in Selden, New York.
Hi, Joe.
Hey, Joe.
How are you, Joe?
You know who Joseph is?
No, but I'm in the dark. Hold on.
Oh, you're in the dark?
I know a lot of Joes from Selden. I grew up in Selden. Miss Stein did.
Oh, did you?
I did. Hold on. This is crazy.
Just go. There you go.
All righty.
You're back.
I mean, I'm no techie, but I'm working on it.
Cheers. It's a COVID edition. Coffee Talk. COVID is 2020.
COVID free. Okay, here we go.
COVID free. Yes. So Joseph's my nephew, by the way.
Oh, how sweet.
He's been watching the show. He loves the show. He wanted to ask a question.
I love it. Thanks for calling in, Joe.
Yeah.
Oh, I forgot the question. He already asked. He was asking about the tomatoes, right?
Love tomatoes. So how are they becoming so much bigger and juicier than before?
That's right. So here's the thing. I love tomatoes. Tomatoes. What I really like is a red, juicy tomato that tastes like dirt in the summer. That's what I really like. It came right off the vine. Delicious. Delicious.
Tastes like dirt?
Yeah.
Oh.
When they're fresh, they taste like dirt.
Oh, you have to clean it all up. Oh, that's a big tomato.
It's big, right? Okay. Well, we talked about the selective breeding. You can hold the tomato for a second.
Oh.
Okay. Careful.
That would have been a cool trick. We have to work on our TikTok skills.
We do have to work on. This tomato was made very, very specially. Now, you could do it two ways. There's the selective breeding like you talked about, where I breed traits. Now, this isn't about a dog. It's about a tomato. But I take the juiciest tomatoes and the reddest tomatoes, and I pollinate those plants just like Mendel used to do, but with selective breeding. And then I can make bigger, juicier tomatoes. I could do that. It takes a long time. That's what the farmers do.
It does take a long time.
Or I could put my lab coat on, and I could go into one of the tomato cells, right in there. I could take out a section of DNA that I don't like and put in a section of DNA I like.
Oh, really?
I know.
Really?
It's like magic.
So you can cut this thing up over here.
Yep. Cut it out.
That's a Nickelodeon show. So you can cut out pieces of DNA and rearrange it to get what you want?
Yeah. You take out a gene from something else and you pop it in. Amazing, right?
Mind
now,
blowing.
let me tell you about the tomato. They really did this. They took out the gene from a fish that doesn't freeze, salmon, and they put it in the tomato so that the tomato doesn't freeze. Now, I don't know. Vegetarians might not be very thrilled that they have a little piece of salmon DNA in there, but this is a true story.
Oh, wow.
The flavor saver tomato.
Wow. And it doesn't taste like fish at all? It doesn't taste like salmon? It tastes
no,
like
they only took out the gene that makes it not freeze. Just that ingredient, just that recipe, just that little section. And they put that in.
So this way, Joseph gets a fresher tomato.
Yeah, you can get anything. So that's why produce, poof, you see that in the store?
Yeah.
Giant tomatoes.
Very cool. Genetic engineering.
Genetic engineering.
Genetic engineering.
Right.
I think I saw that in a movie somewhere with big dinosaurs that go crazy. Oh, yeah. Jurassic Park.
Yeah. Yep. They were way ahead of their time with that movie, I tell you.
If anybody out there hasn't seen the original Jurassic Park that's watching the show right now, go watch the original Jurassic Park.
I agree.
The first one. Not the
tomato egg. This is silence. See Stop.
Bones will catch it. Don't worry.
Aw.
All right. What's next?
Well, I do have another question.
Okay. Give it to me.
This is from Kevin McAllister. He lives in Westchester, New York.
Westchester, New York. Kevin McAllister. Is he home alone today?
He might be. I'm not sure. We should call him up and see.
Okay.
He says, my wife and I, he's quite older than I remember. I think
he's grown up.
Yeah. Have brown hair. Is it possible that we could have a child with blonde hair? Like Miss Meniscus.
Like Miss Meniscus. Yes, there is a way. You can. If you and your wife have brown hair, it's absolutely possible for you to have a kid with blonde hair.
I don't see it. I don't see it. You're going to have to explain it to me.
What you can do is you make something called a Punnett square.
Oh.
Yes. Punnett. Square. Yep. And what you do is you take your genes, whether you're heterozygous or homozygous for your hair color. You take your wife's genes, whether you're homozygous or heterozygous, and you plug them in the Punnett square, and you see what the probability is that your kids will have brown or blonde hair. Now, the way that you're going to have a kid with blonde hair, you and your wife both have brown hair, is if you're both heterozygous for the gene for hair. So that means you have a dominant trait, which would be your brown hair trait, and then you have an itty-bitty recessive trait for blonde hair.
They'll look like this one.
It will look like that. That's exact. Look at right there. No, back from the camera. Back. Nope, can't see it. Perfect. No, yes, right there. Perfect. So both parents are on the outside. That's dad on the top, mom on the side. And then you fill it in like Battleship, and you can see that bottom right-hand corner right there. The two little bees, that's the kid that's going to have blonde hair. If that kid is born right there, that kid's going to have blonde hair for the rest of their life.
Now,
just like Miss Meniscus's.
My thought process here, I'm thinking there's only a 25% chance
There is. Each box is worth 25%.
Like a quarter.
Like a quarter.
So you got like one quarter.
Right. So every time there's a big B in there, that's the dominant trait.
Yeah.
That's going to mean the person's born has brown hair.
Right, right.
There's only, so that's 75% chance that they're going to have brown hair. But there is that 25% chance. It means they have blonde hair.
Oh, boy.
You did that very nicely and quickly, Miss Meniscus.
Thank you. I always like compliments on my handwriting.
Well, cheers to that. Good job. Another cheers.
Cheers.
Cheers. Cheers. Okay. All righty. I guess here we go. This just in.
Oh.
This just in.
I love when we have some last minute calls.
Here we go. This is from Kim in Buffalo.
Oh, Kim, how are you?
Kim in Buffalo. She asks, how are genes used to figure out our family tree? She wants to know about a family tree.
She wants to know about family tree.
Yeah, how do we figure out our family tree using genes, using DNA?
Well, it's like a little code, but there's this thing called a pedigree chart.
Pedigree.
Yeah. And you can use it to trace generations and generation after generation. And what you can do is you can follow a trait. And you can follow it all the way as far as you know to your grandparents and your great-grandparents. Let's just say you want to know where your freckles come from. So you trace the trait. And you use little symbols. You use the circles and the squares. You see that? Circles?
Yes, I can see that. Perfect. Yep.
Okay. So the circle, that's going to be a girl, a female, and the square is a boy. And when they have a line like that, that's it's a marriage or a union. It's 2020, so we can't. I'm not always sure they're married.
This is true.
It's okay. And then we have their children. Okay, so it shows that they have 3 children: a girl, a boy, and a boy. No. Yes.
Yep.
Hard to see from my end.
Yep.
Okay. And then we have 2 more in the next generation.
That's right.
So you follow the trait along.
Okay.
And then you shade the circles or the squares in if they have the trait, and you shade in what we call a carrier if they don't have it, but they're carrying it and can pass it on to their offspring.
Okay, that's kind of like the hair thing that we just talked about with the Punnett square, the brown hair, and then that's because they're carriers of it, even though they might not necessarily have it.
Exactly. And so sometimes we're talking about geneticists do this for diseases if they want to see if possibly the 2 children, if the parents are carrying something, what the chances of passing it to their children would be.
So there's lots of benefits for studying all this genetics.
There is.
I see.
I believe so.
Very good. Very cool.
Yeah, I love genetics.
I do too. It's been a fun unit. I've been enjoying these.
Yeah, I think it's very fun. The kids seem to like it.
Yep.
I agree.
All righty. Sounds good.
Well, that was a spectacular COVID edition episode of Coffee Talk, where we brew up curiosity in New York.
Cheers.
Cheers. Bye, DNA.